All right, ITS148, and today is April 2nd, and I made a slight adjustment to the schedule, the syllabus here. Let me share my screen. Share. And it is that I am not going to bother covering Chapter 13. You can look at Chapter 13, but talks about delegates and indexes, indexers and stuff, and it's not super important, and it's not very covered very much. Chapter 14 is much more important, so I thought I'd spend a couple days there instead. Chapter 14 talks about inheritance. So I made today be the first day of 14, and so Tuesday and Thursday will be Chapter 14. And so if we let's look at the slides for Chapter 14. I'm just going to cover. I'm going to cover the slides today. Let me put this down someplace where I can get at it again. And also the next assignment, I don't have it posted yet, but the next assignment is going to be similar to the exercise in the back of Chapter 14. Let's see, can I look at Chapter 14? Let me bring up Chapter 14 if I can. ITS source. If we look at Chapter 14, that would be in this section probably. No, must be in this section. It's about inheritance. And how inheritance works. And so if we look at Chapter 14, if we look at the last example in Chapter 14, this is a good example. And the assignment, see, this is customer maintenance. And I think the assignment is going to be like inventory maintenance or something. It's you know, there's like three running examples or scenarios that this book uses, and it's the other one that's not covered in either the book or this. It's the one that's not covered in the chapter or the exercises. But I have actually included the solution to that exercise here. So if you look in Chapter 14 here in the resources, chapter exercises, I've included these are the solutions. This one where it says dash, 14-1, 14-2, these are the solutions to these are the solutions to this customer maintenance, right? Customer maintenance, yeah, the solutions. So so you may want to pop those down. I'm gonna put them down here. Put them on. Let's see. Let me put them on the desktop, and I'll open up that. And then the assignment is going to be, you know, apply the same thing to this inventory maintenance. And so it's just going to be complete, you know, complete that, similar to the solution to this here. So I'm going to open this up just to sort of show you what it looks like. And then I'm just going to go through the slides today. Let me open them up. So this is a solution to exercise 14-1, which you have, or you have this solution. And so if we just take a look at it here, we can see oh, what's this? I gotta do something about that. Remember what the answer to this was? Something like that. Where is this customers 14.xml? Where is that? This just worked when I opened it up. Do I need to put two? I don't think that's right, is it? Users. Um, it's supposed to go to. Oh, let me look at this. Already can't. Users open desktop maintenance. Customer maintenance. Wasn't found there. Let me look and see where it is. It's down at customer maintenance. Where is? It's not here. Where? There. It's not going to be in here or here. Well, let me do something different. Let me close this. Looks like it's gone. Okay, let me open up the other one. Just put these here, didn't I? Well, it says. Oh, it says -1. I don't know. Is it on here already? 1, 1. I thought I copied them over earlier today, but I don't see them now. See them, don't see them here. I don't see the database. That's the problem. I don't see the database. Wonder where the database is. Okay, well, I'm going to have to go back and figure out what happened to the. Alrighty, well, I guess I'll have to. It's too bad I can't get this to work. For some reason, the database is gone. Seems weird. I just did it earlier today. Let me look at this. I'm sure this one isn't here either. Yeah, it seems odd. For some reason, the database is gone. Does anybody know? Does anybody know what the problem is? I don't know. All right. So anyway, never mind. But I'm gonna. I will diagnose this. Something that just keeps the database. Let's see. First, let me do one more thing. Let me go down here. I don't think it's going to be down here. It's usually right here. Oh well. Okay. I'll figure that out, and I'll make sure that I have the database next time. Right. Customer maintenance. Okay. Well, anyway, let me just go through the slides here. This chapter is more of a concepts theoretical chapter anyway. We talk about inheritance, and inheritance is it's one of the key features of object-oriented programming languages that makes it able to support large teams working on large software projects much more easily than in the past. It allows you to create classes, and then you're able to create subclasses from classes. You're able to create classes from classes that inherit all of the properties of the class that you're creating the subclass from. So you're able to add to them. You're able to start with a basic class, and then you're able to create additional classes that build off of the original class. And you not only can add to you add methods and properties to a base class, but you can also change the methods. You can override the methods and the properties of the base class. So and there's this concept called polymorphism, which is basically just a fancy word for what I just explained. And so in this example, or in this set of slides here, I'll just go through the slides today, and then on Thursday, I will have given you the assignment, which you start with this. You're going to start with this. Let me just look in here in case I accidentally put it in here. Oh, I don't think I did. Did I accidentally put it in here? Let me just look in here and see if the XML file is in here. I think it is, but let me just check. It's almost like it just gets deleted or removed or something. Okay, well, all right. So polymorphism. Let me put on the slides here. Slideshow. Okay, so here we are. Pick a pen. All right, how to work with inheritance. Okay, so in this chapter, the objectives of this chapter is we're going to, well, the purpose of this chapter is we learn to use the features of inheritance that are presented in this chapter to develop classes for our applications. Now, we've been using this all the time. I mean, we've been using this all along. In fact, when we create a form, we start with a form class. We always start with a class that is provided for us in the .NET framework, and then we add to that. And so when we define classes, we always say, private or public, class name, colon, and then some base class name, and that's exactly what we're doing. So we're gonna, once we're done, we're gonna be able to explain inheritance used within the .NET framework of classes and how we use it to build our own classes. We've been doing this all along. We'll explain how we might want to override some of these methods that we're already are provided for us. This is like stuff that's covered in chapter 13, which we're not going to cover, so it's not that important. We're going to learn about describe the use of protected and virtual class modifiers, access modifiers. We've been using public and private, and we're also going to learn about virtual and protected, and we're going to be able to describe polymorphism better, and we're going to describe the use of the type class and explicit casting that we're going to need to use when we're dealing with objects of the base class. You'll see what that means. Derived classes. And then we're going to learn about abstract classes and sealed classes. Abstract classes are simply classes that, so all the classes that we've been talking about so far, you can create a subclass or extend it by using a particular class as a base class, and then creating another class based on that base class, where we add stuff. But the base class has always been a class in itself, where we can define objects using the base class. But an abstract class is a class where you can't really define objects using the base class. The base class is the abstract class, and it's a class that doesn't really have any, there's not really any methods or properties defined in an abstract class. It's just a class that can be used as a base class to create another class. And then a sealed class is simply a class where you cannot define a subclass from. So there's certain cases where you might want to do that. Okay, so this is an example of how inheritance works, and we're going to use the form class that's provided in .NET. And in .NET, forms all have this text property, and they all have this minimize box and maximize box property, and they all have a close method, they all have a show method, they all have this dialog results show a dialog method, they all have that. But then what we do is we come along and we can create a new class, a new form, which is a class, and we add stuff to it. We add some text boxes to it. We add some buttons to it. We add some methods to it. And so it's a derived class. It's a class that's derived from the base class. So we've been doing this all along, and in this chapter we're just kind of learning about it formally. And we're learning about some of the other things that you can also do that we haven't been doing, but we can do that. So the inheritance hierarchy for form classes, or form control classes. Everything is derived from this object class, and in this object class there's a control class, and all the controls that you put on a form are derived from this control class. And there's buttons, and there's group boxes, and there's labels, and there's lists. There's a list control class, and from the list control class we have combo boxes, which we've used, list boxes, which we've used. There's text boxes, which are derived from the text box base class. The reason that there's actually a text box base class is because there's actually a couple of other kinds of text boxes. There's something called a rich text box. We don't use any of those in this class, in ITS148, where we only use the text box class. But the rich text box class, you can do fonts and so on. There's scrollable controls, and from which a container control class, and then a form is based off of that. So these are some methods that are provided by the basic system object class, this basic system thing here. And they all have these. We don't really use them very much or at all. Talk about this in chapter 13 a little bit, which we're not going to cover. But these are used to, for example, if we want to compare if a class is the same, or if an object is the same as another object, or if it's derived from the same class, or that kind of thing. So in this product maintenance application, we have this product class, and we're going to use this example throughout this chapter. We have this base class called a product class, and the product class simply has a property which has a code. It's a string. It's got a code, some sort of book code or software code, or what, price, like the product code, for example. And there's a description, and there's a price. And then there's this method that we can use to display out some information about the particular instance of that product. So, we might have the code followed by the description followed by the price, for example, and that's what's displayed out when you invoke this getDisplayText method. The string here happens to be the delimiter, if you recall. Okay, so from this product base class, we can derive two new classes that are actually classes that we're going to use. We may not even use this thing here. Okay, we're just going to we just create this thing first because this is stuff that is common in both of the types of products that we are going to use. Let's say we're a store or something. We sell stuff, and let's say we sell books and we sell software. And software and books, they're both products. They both have these common properties and this common method. But the book class also has this other property which is not present in the software class, and that is an author, okay, for example. And the software class has this other property which is not in the book class, and that's a version. So you might have a software version, and you might have a book author in this example. And then we have also we have this this other thing called a list. This generic class, so this list class, which is part of the collections .NET classes that are provided for us, and list, and we've used list before. List has these basic methods that come with it: an add and a remove, and an index, basically. And we may want to create a product list class which contains these things, but also adds a couple of other things like fill, which will fill a list with a bunch of products, and then save a list, someplace, save it out into the database or something. So we would start with the basic list class, and then we'd derive this subclass from the list class. So here's an example. So here could be the product class. Okay, this is the base class. We aren't going to be creating any objects from this class. We're only going to create we're going to create two subclasses from this base class, and then we're going to create objects from the subclasses. But we'll start with this base class, and this base class, from this example back up here, has these properties, these three properties, and this this method here, which displays out text. If you input a separator, a tab, character, or a comma, or something, and it'll return a string, and with the code followed by the separator, followed by the description, followed by the separator, followed by the price, string version of the price. And virtual simply means we're gonna override it with our own with a method specific to the base class, or specific to the subclass. So these are possible access modifiers, and we're familiar with public and private, but there's also protected, which means it's available only to the current class or its derived classes. So protected is like private in that it's not available to any other classes outside the base class or the derived class, and it's like public in that it's available to any derived class, but it's not outside. There's internal, which means it's available only to the classes in the current assembly, as they say. Protected internal means it's available to the current class, derived class, or the current in the current assembly, or the derived classes in other assemblies. So the syntax for creating subclasses is and we've been doing this. You can have the access modifier here, public, the word class, and then this is the subclass name based on the base class. And so, like, for example, when we create forms, you'll notice that we let's see, do we have an example of that here? In this thing here, the form. These are forms. And so when we view the code, we see this. So this is the base class, and this is the subclass. This is ours. This is what we have, but it's based on the form class, which comes from here. See. slideshow from current slide. So so this is to create a constructor that calls the base classes we have now. We haven't really seen too much of this yet, but so this is a constructor. So we have the class name and the parameter list, and then all the rest of the, you know, these are parameters that are unique to the. These are the parameters that are unique to the subclass, and then all the rest of the parameters that are provided by the base class. To call a base class method or property, so this is a base class method or property, you use the word base in front of it, and so these are methods or properties that are defined in the base class, and then if you want to define your own you know, method or property, the same name, you can override it by doing something like this, or you can override it by doing something like this, or you can create a new one by doing something like this. So this override a virtual method or property would mean that you've got something like this in here, and you're going to override it. You're going to make your own. So it's going to have the same name, and you're just going to make your own. So you just define it this way. So for a book, so you remember we have software and books. So here's how we may define a book. We have we're going to add, it's going to defining a class called book. It's based off the product class, so the book is a subclass. And in addition to the properties of the product class, we're going to add an author, and this is the constructor for it. And so the constructor has a code, a description, an author, and a price, and it's you also and it's from the base class here. I guess you do you do include those in the constructor here for the subclass, and then but these are the same. That is, these are the same. These and these are the same as defined in the base class. Which do we have an example of that here? This. So these all apply, but we also add, you know, the author. So in this constructor, we only need to specify what's in addition to what's already in the base class. And then we're going to define our own get display text. So we're going to override the base class display text method. And so this is a completely newly defined method. And another way to override the method is to you can use the start with the base class method, the one that's already defined in the base class, and then we can add this to it. Do it this way. So 3 versions of the get display text method. So a virtual get display text method in the product class looks like this. And it's going to be, because it's virtual, it can be overridden this way it can be overridden this way for the book class and overridden the same way for the software class. So we take the base one, which is this one, and we use it in both cases, and then we simply add this on for the book, and we add this on for the software. And so here's code that uses it. We're defining a book. We're defining an object based on the book class called B, and this is the constructor. So it's got the arguments to create a new book, which is the book, our textbook, happens to be our textbook. And then we're creating a new object, which is a software product called S. This is the constructor for it. This is the code and the description and the what is the third parameter here is the price. That's right, the price. The price and the version. This is the price. So is book is actually, book has got author then price. Let's see, software. All right, so so here's the product. This is the product maintenance class, and yeah, okay. So this is the software I have to find. I have to find this software for you so you can take a look at this example yourself, and I'll try to put this up before next Thursday. So you have this maintenance form that looks like this, and look, we've got some software. No, we've got a book, got some software, and got a book. And we can add a new product, or we could delete a product, or we can exit. And when we add a product, we click on Add a Product here, and this thing comes up. This is just one form, but when you click on the book radio button, it looks like this, and notice it says author here. And when you click on the software radio button, it switches and it looks like this. So version, it shows version instead of author. So this is not two different forms. This is one form that actually changes when you click on the radio button. So your code has to be able to do that. So the code for the product class looks like this. Okay, so this here we just go through the code for the product class, and it's quite simple. It's first we start out with the this is the property. We got these three private variables here, properties, code, description, price. This is the constructor that's got no parameters. This is a constructor where you can send in these arguments or these parameters, and it creates a product that's got these three things in it. And this is this is the accessor for the code, get and set. This is the accessor for the description, and this is the one for the price. And this is the method which you're going to be able to override to display out the attributes of the properties, the description of the product, the particular product. And so for the book class, this is how we define it. We say public class book, and it's based off the product class. And we're going to add an author. And this is the constructor for the book class without any parameters. And this is the constructor for the book class where we can define all the parameters, the code, the description, the author, and the price. And the code, description, and the price are the same as the base class. And so we have to only add the author. And so then we only have to add the accessor for the author. And then here we override the method, the get display text method, by using the method in the base class, the virtual method get display text method in the base class, and we just tack the author onto the end of it. And for the software, look at this for a second. Description, code, description, author, price. Code, description, version, price. So this is the software class, same kind of thing. We're defining a new class called software. It's based on the product class. We're simply going to add a version property. This is the constructor, the parameterless constructor. This is the one where constructor that's got where you can put in all the parameters, put in all the properties for the particular object that you're creating. And this is the accessor for the unique property, that's software of software. And then this is the get display text method for the software class, based on the base method. And then so here's a code for the list, for a product list. And this product list can store either software products or book products. And so it's a product list, which means it can store any objects that are of classes that are based on the product class. And there's we're defining a method. This is the product class, and we're defining a method called add. We're actually overriding it because there already isn't. There's an add method in the. I think there's an add method in the list. In the list class, or maybe there's not. I can't remember. But it used. Oh yeah, there is. There's an add method. There's an add method in the list class, but it adds objects onto the end of the list. And we want to change it so it adds products onto the beginning of the list. So that's what this does. It overrides the it overrides the add method in the plain old list class to this, which is inserting the product onto the front. It inserts it into the front of the list. Okay, so that's different. And then we're going to add another. Modify the behavior of the add method. So this modifies the behavior of the add method. And then this, we add another couple of methods here that are not present in the list class. One of them is fill, which is going to read. It's going to go out to this database. Use this database class. It comes along with the program, which accesses the XML database, which doesn't seem to be included in the zip file I zipped up to give you. And there's a method in there called getProducts, which returns a list of products. And so that's what this assignment does. This thing returns a list of products and stores it in this products list of products. This loops for each product in product and products. Okay, this is a list of products that is returned here, and then this thing loops and adds it to our product. Oh, it adds it to. Oh, it add this. This is. I'm sorry. This. This loops and adds it to our product list class. This thing. And then this does the reverse. This saves it back out again. All right, so this is the code for the product maintenance form. This is the sort of the final code. This is the form itself. It's, this is provided by .NET, and this is the reason it's partial because there's also the .cs file. It's the rest of it, and it's called form product main, and this initializes it. We define a product list of products. Okay, this is our product list class that we've defined back here, which is similar to the list that's returned here, except for we are adding it to ours, which uses our add method, which sticks them onto the front of the list instead of the back of the back of the list. So it pulls them off one at a time, sticks them onto the front of the list. And this here, this is the load handler. When the form loads, it's going to call products.fill, which is this. It's going to call it, and this is going to fill product list box, which is going to this thing here, which displays it up onto our list box, which is this thing. This is the list box, and it's going to fill it up using this get display text. So that's why it looks like, this is slide 25. That's why it's going to look like this. See, this is the code tab, the price tab, description, parentheses, author, or the version. And when we add a new, we want to add a new product, this is the add, this is the click event handler. We pop up a new, we pop up a form new product, object called new form, and it does its thing and it returns a product. And so it returns an object. It's either going to be a software product or a book. As long as it's not null, we add it to the product list, and then we save it back out again into our database, and then we fill up the list box on the main form, so it displays the new product list. This is going to delete. So this is the list box, and selected index. There's going to be one of the products will be selected, as long as one of the boxes is, one of the products is selected. This is not going to be -1, it's going to be something else. And this is going to take it, and it's going to ask, are you sure you want to delete it? If yes, if it's yes, then it's going to use the remove method that's provided in the base class, the list, the plain old list base class. And so it'll remove it, save that back out into the database, and display up the display it into the list box again on the main form, and then this closes it. So this is the code for the new product form, which this is slide 28. This is going to be this thing. It's going to be either this, or it's going to be this. It's going to be one of these. And so it's going to show that it's going to pop up the dialog box, and it's going to do its thing. And first of all, well, it'll save will cause it to be done, and it'll return the product. If the radio button changes, means someone clicks on the radio button. If the book is checked, then it's going to make the text, the author or version, say text, or it's going to make it say author. And then it's going to also say tag. The tag, which is going to be returned with the product, it's going to be the tag that's a property of this. It's going to say author. Otherwise, it's going to say version. And what this is actually is what makes this thing say author or version. And and then presumably they'll type in all the other information, and then the user will click the save button. And when the save button is clicked, it'll execute this isValidData method, which they provide you, and it looks to see if it's a book. If the book radio button is checked, it's gonna. Does this thing default to? This thing should default to author. It probably does. It probably defaults to author. If the radio button is checked, it's going to create a new object, a new book object using the book class that we defined earlier. This is the constructor for it. It's going to be the contents of the text box, which contains the code, the contents of the text box, which contains the description, the author or version text box, the contents of that text box, and then it's going to take the price, convert it to a decimal, and it's going to use those 4 arguments to create a product object. It's going to be a book type object. Otherwise, it's going to be a software type object, and it's going to use the same fields to create that object. This is the isValidData method, or this uses the validator class that is provided for us, and this is canceled. So there's a type class which returns for a particular object, it returns the type, and that's the it's basically the name. Do we have an example here? Yeah, it's so it looks like this. This is how you use it. Um, you've defined a product like this. This is P, and then you can say then you can define another object called T, which is a uh, a type class. It's an object that is a type class. That's the name of the class, and this is how you define it. And it has these properties. It's got a name property, it's got a full name property, a base type, and a namespace, and it's got a method. And this is the method returns the type, a type object that represents the type of the object. It's kind of confusing because the word type. But you use this if you want to sort of go in reverse and remember what exactly the object is. Okay, so you have this object called P, and let's say this part was done someplace else, and you're working someplace else in your code, and you want to remind yourself of what P is. You can just define a new object, a type object called T, and you assign it to this, and then T.name is going to give you the fact that this is the type of object it is. It's a book. Okay. So we define here. It's going to you can see what the namespace is. The namespace is going to be this is where it's defined. You can get the full name, which is the namespace followed by the type of object it is, and then you can also get the name of the base type, which is the base class from which the base class from which this subclass was defined or derived. You can also test to see if this is a book object if you want, or you can test the name to see if it's. So these are also valid ways of testing the object type. Two methods to display the product information. So you can display product, and it takes display product. It takes a product P, and then this displays out the display text from product P, or you can do display book, and this displays out the same thing. So okay, and then there's casting, and you recall casting for if you have to. There's implicit casting and there's explicit casting. If you have one object type and you want to cast it as another, you can. If you have a book, okay, so here we're displaying a product here. So this is the base. This is the base class, and this is the derived class. So a book is a subclass of product. Okay, so if we use if we want to display out a product, and so this is the main class. This is the base class. So we're using display product, we're displaying out the base class, and then this is a subclass. So if we want to display the product where we're using the base class display method, and we use as an argument a subclass, then we don't have to use casting. Okay, so it's able to figure it out. But here, if we have so here we've defined this is the subclass book B, and the constructor is of course a constructor to construct a book object, and we can also construct a book object, but we can say it's a product. This is the base class, a product called P, and we're going to create a book object, and the type is going to be a product type. So this is the base class, and this is the subclass. If we want to display the book, and we're using P because we've defined the object as a product, it happens to be a book product, then we do have to use casting. I know that was probably confusing, but it's covered in the book, so I thought I'd cover it. And if we do something wrong, it can throw an exception. Like here's an example where we're defining a product, and it's a software product, but we're using the product class designator, and then we try to display it as a book, and we try to cast it as a book. Then of course it's going to cause an exception because P is not a book. P is a software. We can do it without causing an exception by using the as operator. So it's just going to pass back a null. All right, and then the final couple of slides here is an abstract class. Is you just define it this way, and you don't really declare any private variables to store the properties. You don't really declare the method. You don't define the method. This is just sort of a template, and then so you're able to create subclasses from this base class, but you cannot create an object from the base class. You can only create subclasses and then create objects from the subclasses. And a sealed class is sort of the opposite. You can create a sealed class, and it doesn't allow you to create any subclasses. So if you want to create a class and you don't want anybody to ever create any subclasses from it, you want to create this base class, but you don't want to allow any subclasses to be created from it, then you can create a sealed class. It's the word sealed, and it can be a little bit more efficient because it doesn't have to add all the hooks and stuff along with it to allow a subclass to be created from it. You'll probably never use this. You'll probably never use either of these abstract classes or sealed classes. So anyway, that's it. This is the customer maintenance application that uses inheritance, and this is the software. This is the example the exercise I tried to provide for you. I'll make sure that works next time. And then this is going to be what the assignment is for the next assignment. All right, so that's it's 3 o'clock. So that's inheritance. Inheritance is a pretty important topic. All right, so I will see you Thursday. Thanks for watching.